Hi there, folks. Today we're looking at polygons in the coordinate plane. And so as we look at these things in the coordinate plane, we really just need to identify certain aspects of this thing, like the length of each piece of this thing, or the angle at which they come together, whether it's parallel or perpendicular, that kind of thing. And so maybe we look at something like the midpoint. So just a couple refreshers here. The midpoint, remember, is basically the average of the 2 points. I always think of it as the average. I don't memorize formulas. I say the average of the x's. X is divided by 2. Y is divided by 2. It's the average of each of those gives me the midpoint, okay? The distance formula, here it is. You can use the distance formula. You can remember the distance formula. I always use the Pythagorean theorem for this. So like, again, this guy, just the average of x and y separately. This one, I always use the Pythagorean theorem instead. It is the Pythagorean theorem. You just have to think about the side lengths in terms of counting. And we count it the same way as rise over run. And then slope itself, I always do from the graph, either rise over run or change in y over change in x. You could also do the slope formula, where it's the difference of the y's over the difference of the x's. Just make sure you subtract in the same order each time, and make sure you have those y's on the top. The other thing we have to remember about slope is when we're talking about parallel versus perpendicular lines. And so for slope, if we have parallel lines, remember the slopes are the same. And if we have perpendicular lines, the slopes would be opposite reciprocals. Okay, and so just remember those things as we start to compare these, because we're going to plot these, and maybe we'll know, is this thing a parallelogram? Well, that's important to know if we have parallel lines in a parallelogram, okay? And we're really just going to use all the properties that we've learned between, parallelograms and rhombuses, rectangles, squares, trapezoids, kites, things with triangles, and we're just going to put it all together. As we plot these things, as we see these shapes on the coordinate plane, we want to make the best determination about those shapes, okay? And so if I look at something like this guy, we're starting with a triangle here. It says determine if triangle ABC is scalene, isosceles, or equilateral. Remember, scalene just means that none of the sides are the same. Isosceles means exactly two sides are the same, and equilateral means that all the sides are the same. And so really, I just need to plot this, and I need to find the length of each side. And so if I plot each of these, ready, here we go. So -3, -1. There's A. 1, 2, right here, that's B, and 4, -2, right here, that's C, okay? And so here's the triangle that's formed, and so as we look at this thing, we're probably looking at it going, okay, I don't think it's equilateral, because it looks like AC is longer than the rest, but we don't know for sure. All right, it looks like it might be isosceles. AB could be the same as BC. And so what we have to do is we just have to find the length of these, okay? And so if you want to take this off to the side and do your distance formula, that's fine. I'm just going to count. I count from A to B, and I say, oh, that's up 3 and over 4. And so that's my Pythagorean theorem. It's up 3, so 3 squared over 4 plus 4 squared equals, well, that's going to equal the length of AB squared. Okay, and so keep that in mind, that's C squared. So it's just A squared plus B squared equals C squared. Okay, and so here that's a 9 plus 16. So I'm going to get a 25. So I find out that the length of AB is 5 units. Okay, and now I could do the same thing with something like BC. Again, I just do a little counting and say, oh, it's over 3 down 4. And so if it's over 3 down 4, that's 3 squared plus 4 squared. And that's going to equal the length of BC squared. It's C squared. Okay, if you want to just think of it that way. You don't have to write the BC squared or whatever. I'm just showing you which one I'm finding this time. And you're probably looking at this going, Mr. Jansen, you have the same thing written. Do you really need to take this all the way to the end? And really the answer is no, okay? You know right away that these are going to be the same length as soon as you set up your Pythagorean theorem, okay? And so as you look at this thing, if you count and it's the same distance up and over from one point to the next, well, of course, the Pythagorean theorem is going to give you the exact same thing because it's the same values for A and B, okay? And so there's a lot of shortcuts built in here. You know, it's always funny when students will find the actual length of each of these things. Do I really need to find the length of AB and BC to know that they're the same? No, I can literally count, say, oh, if it's up 3 over 4 and the other one's over 3 down 4, if those lengths are the same for my counting, then yeah, of course, that third side is going to be the same, okay? That's how right triangles work. That's how the Pythagorean theorem works, okay? And so right away, I now know that AB and BC are congruent. Well, let's check that with the last side. If I look at the last side here, it's down 1 and over, it's like 7, okay? And here's the thing, I suppose it's possible, especially as we start to get into square roots and decimals and that kind of thing, that we could have things that don't match up and could be the same as we kind of get that length. So let's check the length of this one using our Pythagorean theorems. Let's see, it was 1. I don't know why I have that in parentheses. So 1 squared plus 7 squared, and that's going to equal AC squared. And so right away, even before I get anywhere close to the end of this thing, I can see that it's not going to work. It's not going to be the same. And so I look at something like this guy. That's going to be the square root of 50, which is a 5 root 2, okay? Or plug it into your calculator and write it as a decimal. But now we can see that these sides were the same, and this one was not, all right? And so now to finally answer the question here, as I look at this thing, I have two sides the same, so this is an isosceles triangle. And that answers the question. This one's isosceles, okay? If I look at something like this guy, it says classify the quadrilateral with vertices A, B, C, and D. So let's plot these once again. So I'm just going to plot these so we can see what it looks like. So let's see, we've got -2, -1. That's A. 0, 3. That's B. 4, 4. That's C. It's a terrible looking C. And 2, 0. That's D. Okay? And so again, if I connect these, if I look at something like this guy, with quadrilaterals, there's a lot of things that we want to look at here, okay? And so there's a couple ways to kind of classify this. First of all, we want to figure out, is the thing a parallelogram? And then if it's a parallelogram, we have a lot of subcategories from there. Is it a rhombus? Is it a rectangle? Is it a square? Okay. If it's not a parallelogram, we look for things like, is it a trapezoid? Okay. Or is it a kite? That kind of thing. Okay. And so, first of all, the first thing I'm going to check is the slopes of each side. I want to see if this thing's a parallelogram. And so if I look at the slope of each side, the slope of this top side right here, let's see, it's up 1 over 4. So that's a slope of 1/4. And then I check the opposite side to say, okay, over here, to get from A to D, it's up 1 over 4. So that's also a slope of 1/4. So now I know that these opposite sides right here, BC and AD, are parallel. Okay? So I'm well on my way to maybe this thing being a parallelogram. So now let's look at AB. Say, okay, the slope here. That's up 1, 2, 3, 4 over 2. So that's a slope of 2. On the other side, that's up 4 over 2. So that's a slope of 2. So these sides are also parallel. And so right away, I can tell that this thing is a parallelogram because the opposite sides are parallel. That's the definition of a parallelogram. But now let's look for subcategories from there. I could look at this and say, okay, I can tell that this thing is a parallelogram, but then from there, is it a rhombus? Is it a rectangle? Is it a square? And we already have the answer to whether this thing is a rectangle. I can tell if this thing is a rectangle by looking at the adjacent sides. I could look at BC and AB, something like that, and say, hey, are those perpendicular? Do they form a right angle? That's the definition of a rectangle. And so when I do that, I just compare these slopes and say, hey, are these slopes opposite reciprocals? And the answer is no, they're not opposite reciprocals. So A, B, and BC are not perpendicular. So there's no way that this thing could be a rectangle, okay? And if it's not a rectangle, we also know it's not a square. So right now we have it narrowed down to parallelogram, but maybe it's still a rhombus. And there's a couple ways you can check to see if this thing is a rhombus. One, we could find the length of each side. We can compare to see if all the sides have the same length, okay? The other thing we could do is we could draw the diagonals, okay? And if I drew the diagonals in here, well, I could find the slope of each diagonals. And I like doing this because I think that it's always faster to find slope than it is to find the distance of something. And so if I found like the slope, I'm going to come off to the side because it's getting a little crowded in there. If I found the slope of AC, it's just counting. It's up 1, 2, 3, 4, 5. And then it's over 1, 2, 3, 4, 5, 6. Okay, so there's the slope of AC. If I found the slope of BD, again, to get from B to D, it's down 1, 2, 3, and over 2. So down 3 over 2. If this thing were to be a rhombus, then the diagonals would have to be perpendicular. So I look at these slopes and say, hey, are they opposite reciprocals? And the answer is no, they're not. So this one can't be a rhombus. So the best classification I can make here is parallelogram. And that's it. Okay? And again, there's lots of ways to approach this. I went the route of looking at the diagonals. And if I wanted to know if this thing was a rectangle, I could also look at the diagonals and see if their lengths are the same. Okay? And so there's a lot of times where we could do this entire thing just looking at slope, or we could do the entire thing just looking at length. Okay? And so really you want to find the route that's most comfortable for you. If you're looking at this going, I really don't like comparing the slopes, Mr. Jansen, I get really confused with that opposite reciprocal thing. Well, that's okay. So you could look at this one, and after finding out that there's a parallelogram, you could just look at the diagonals and say, hey, are the diagonals congruent? And you could find the length of each of those, and if they're not congruent, then it's not a rectangle, that kind of thing. So you could look at the diagonals here. You could also look at the diagonals and just say, hey, with those diagonals, do they bisect one another? Because that would also tell you if this thing was a parallelogram. Okay, you could find the midpoint of BD, and you could find the midpoint of AC and see if they're the same using your midpoint formula. So again, there's lots of options here, but we want to work through some of those properties, and we want to do it in an order that makes sense. Okay, we don't want to start looking for, is this a rectangle, before we determine if it's a parallelogram. Okay, and so we want to work through those bigger categories down to those subcategories. Okay. If we look at this guy, it says classify the quadrilateral formed by connecting the midpoints of KITE. And so this time, we're not just identifying the quadrilateral that's given. We're identifying a new quadrilateral that we're going to create using the midpoints of a previous quadrilateral, all right? So let's draw this kite first. So let's see, K is -5, 0. Then -1, 4, -1, -4, and 7, 0. Okay? And so as I look at this thing, this was K, this was I, this was... sorry, these are written in the wrong order. I'm going to call this guy T and this guy E. Okay? Okay? And so if I look at this thing, and it already told me that this thing is a kite, and I could figure that out by drawing the diagonals, seeing that they're perpendicular, but then also seeing that this thing is not a rhombus, okay? Because remember, the kite and the rhombus share that characteristic, those perpendicular diagonals, but the rhombus would also have congruent sides. So I could easily find out that this was a kite, but it asked me to find the quadrilateral formed by the midpoint of this thing, okay? And so again, midpoints, it's just the average, or halfway up, halfway over. So to get from K to I, it's up 4 and over 4. So it's up 2 over 2. There's the midpoint of KI, and I'm going to call it A. All right? Let's find the midpoint of IT. Again, it would be down 4 over 8. So I'm going to go down 2 over 4. There it is. I'm going to call that one B. To get from T to E would be down 4 over 8. So I'm going to go down 2 over 4. It's actually right here. I didn't draw it very well, apparently, because I missed that point. And then the midpoint of this guy, it's up 2 over 2, depending on which way you're counting. So that's D. Okay? And so the question asked me, hey, what kind of quadrilateral is this guy? What kind of quadrilateral is A, B, C, D? Okay? And so I could literally erase the kite that I've drawn here. And if you want to do that, if it makes sense for you to get rid of that so it's easier to see this thing, that's okay. I want to determine what kind of quadrilateral this guy is. And so as I look at this thing, you probably have some theories already, but let's make sure we go through the motions here. So you're probably thinking, well, look at it, Mr. Jansen, it's a rectangle. Okay, well, let's confirm that. To show that it's a rectangle, first I have to say it's a parallelogram, so look at the slopes here. So here the slope is 0. Here the slope is 0. Here the slope is undefined because it's a vertical line. Here the slope is undefined because it's a vertical line, okay? And so right away I can look at this thing and say, hey, this is parallel to this guy. These other sides are parallel, so it is a parallelogram. I've confirmed that because the opposite sides are parallel. And now I look at this and say, okay, when I compare AD and AB, 0 versus undefined, are those perpendicular? And the answer is yes. So that tells me that this thing right here, that this guy in the corner is a right angle. And I could go through and show each of these as a right angle very easily. So now I know for sure that it's a rectangle. But what about it being something like a rhombus as well, making this thing a square? Well, all we have to do is find the distance, have to find the length of each side. And see, I would go the route of length for each side this time because they're easy to count. I can just look at it and say, oh, AB, well, that's 1, 2, 3, 4, 5, 6 units just by counting. And then compare a consecutive side. Look at something like BC and say, okay, I can count the length of that side. It's 4. And so this thing can't be a rhombus, therefore it can't be a square because not all the sides are the same, okay? The other option there is I could have drawn the diagonals, see if they're congruent. Okay, and that would tell me if this thing is a rectangle as well, all right? But it's more difficult to find BD than it was to find BC, which is why I went the lengths of the sides this time, okay? So again, it's all about finding the easiest path here to get to where you need to go, all right? And narrowing it down and going through the steps, all right? It's not just about identifying that this thing is a rectangle. It's about justifying how you identify that. So let's confirm it here. This one's a rectangle, okay? And I know that because I went through, I found that this thing was a parallelogram. I showed that, and I found that it had 4 right angles. But then I also showed that it could not be a square because it doesn't have all sides congruent, okay?